Welcome everybody to exercise 1 on page 10 of the workbook. Let's take a minute to read this. So they're telling us that the position of a particle moving along a straight line in meters is given by s equals 6 over t, where t represents time in seconds. Okay, and they would like us to calculate some average velocities over the intervals that were given. Okay, so let's start by just pointing out that this 6 over t that we're given, that's our function. So we could also write s equals f of t equals 6 over t. Okay, and then part A is asking us for the average velocity between 1 and 2. Okay, so we can write that down using our notation AV from 1 to 2. And we talked about how we're really just calculating a rise over a run when we do that. So our average velocity is going to be f of 2 minus f of 1. That's the distance that we moved over the amount of time that went by, 2 minus 1. Okay, and to actually do the calculation, we need to think about the function that we're given. So for example, f of 2, that's asking us to take the time value 2 and substitute it into our function. So we're going to get 6 over 2 for that. Okay, and then similarly, f of 1 is going to be 6 over 1. We'll divide that by 2 minus 1. And see what we get. So let's see, 6 over 2 is 3 minus 6. Okay, and 2 minus 1 is 1. So we're going to wind up with an answer of, it looks like negative 3 here. Okay, what about units? So that negative 3, what would the units on that answer be? Okay, well, let's see. We're measuring distance in meters and time in seconds, and so we should get units of meters per second here. Okay, there is our average velocity for that first interval. Okay, what about from 2 to 5? Well, exactly the same idea there, just a different time interval. So this time we'd be measuring f of 5 minus f of 2 over 5 minus 2. We're going to substitute those two t values into our function and get 6/5 minus 6 over 2 over 5 minus 2. Okay, and if you do that calculation, okay, you can check this by doing it on your own. You're going to, what you should end up with is negative 0.6, and the units again are going to be meters per second. Okay. Now, maybe one just follow-up question that I could ask. So we got negative numbers for these velocities. Is it okay to get a negative velocity? Well, what does that mean when we get a negative velocity? Well, if you think about it, that's just really an indication of direction. Okay, so we've got a particle that's moving along a straight line. Okay, and so you can think of these negative velocities as just indicating that it's moving in the negative direction. Maybe if in this problem we chose to call the right direction positive and the left direction negative, it's just an indication of motion to the left. Okay, so negative velocities are okay. They're just an indication of direction, as it turns out.